The next topic will be decimal fractions. In our number system, the figure's place in the number shows what it is worth. It is a decimal system since each place value is based on 10. In this system, fractions appear in the columns right to the decimal points. They are called decimal fractions, or we can just call them decimals. So when we're looking at the board, we have millions, which is 1,0,0,0,0,3 zeros. If you are not able to see it well, please zoom in, because I think the writings are small. So you have to zoom in. We have hundred thousands, 10,000s, thousands, hundreds, tens, units, or ones. And all these are called whole numbers. And then we have the decimal point. And then moving to the right, we have tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. The difference is just you have to add THS to all of these, and then it becomes decimal fractions or what? Fractions. So let's take tenths for example. This can also be written as 0.1. That is why we call it decimal fraction. Okay, it can also be called fractions, but because we can put a decimal into the numbers, that is why it's called decimal fractions. So the decimal point in a number separates the whole number part from the fraction parts. For example, we have a number 35.462. So right after the point, we have ones or units, and then we have tenths. So we can call it 3/10, okay, and then 5 ones. Point after the point we go to tenths. So 4/10, 600, and 2,000. Okay, so 35.462 is 3/10, 5 ones, and a decimal point, then 4/10, 600ths, 2,000ths. So if there should be another number here like 6, what will it be? So let's see, 5 ones, 3/10, then 600. So right, 600s, and it goes on and on. Okay, and this goes on and on. And then also you have to know that after the point, you see the numbers in a digit form. So this will be 635 point. After the point, you can't say 462. No, you have to mention them one after the other. So 635.462. 635.462. And then whenever there is a point or a decimal point, just before it, just place a zero. Okay, so let's say we have 0.8, just put a zero, so that it will be 0.8. Like we have 0.352, just put a zero, then we will have 0.352. A number like 0.6, 352.1, these will be said to have only one decimal place. Why? Because after the point or decimal points, there is only one number. After the decimal point, there is only one number. Okay? Alright, what about this? After the decimal point, there are two numbers, 3, 5. The decimal point, there is two numbers, 5, 3. So it is said to have two decimal places. Now what about this? After the decimal point, we have 1, 2, 3. For the decimal point, we have 1, 2, 3 numbers. So it will be said to have what? 3 decimal places. Go on to the subtopic changing decimal fractions to common fractions. To change a decimal into a fraction, we look at the last decimal's digits. Its place value tells you what the denominator of the fraction will be. The digits show how many of that fraction you have, and that is the numerator. For example, 0.7. The question said change 0.7 decimal fraction to a common fraction. So just look at the natural number after the point, put it at the top as the numerator, bring the division sign or over, then ask yourself after the decimal point, how many digits follow? Just one. So you put tenths. Okay. Okay. Another example. Let's say we have 0.8. In the same way as we did this, we write 8 over 10. What about 0.78? The natural numbers are 7 and then 8. So they will be the numerator. Then over how many numbers comes after the decimal point? 1, 2. Then we'll put 1, 2 zeros. Okay, what about 0.078? Now, whenever there is a zero, ignore it and just jump to the natural numbers. So we write 7/8 over how many numbers comes after the point? 1, 2, 3. So we write 1, 2, 3. But if it was to be 0.708, we can't ignore the zero because it's in between natural numbers. So 708 over how many numbers comes after the point? 1, 2, 3. So 1, 2, 3. Okay. All right. Let me give you another example. 0.0708. So after the point, the zero, we will ignore it. We always pick the natural numbers. But then when a zero is in between a natural number, we include it. So 708 over how many numbers comes after the decimal point? 1, 2, 3, 4. So 1, 2, 3, 4. So these are some of the examples when you are moving from changing decimal fractions to common fractions. And we can have decimal fractions like 3.7. Okay, this time around it's not 0.7 but 3.7. And then let's come to the table. 3 means it's a whole number because it comes before the point. So it's a whole number. And then point. Every number is what? Decimal fraction or a fraction. So if you are told to change 3.7 to common fraction, 3 whole number, then 7 over after the point, how many numbers come? It's just one. So 3.7 is also what? 3 whole number, 7 over 10. Okay. All right. Let's see more examples. Let's write 13.290. And then we are told to change this decimal fraction to common fraction. Again, there's a point on the left is what? Whole number. So 13 whole number. Then all these will be what? Our numerator. 290 over how many numbers comes after the point? 1, 2, 3. So 1, 2, 3. So 13.290 is also 13 whole number, 290 over 1000. Now we move from changing common fractions to decimal fractions. So to change a fraction to a decimal, we divide the numerator by the denominator using the long division method. You can just use the calculator if you are timed. Okay, so we have 3 over 4 as a common fraction, and then you are told to change to decimal fractions. Okay, all right, so if you are timed, you just put in 3 divided by 4, get 0.75, and you are done. But let's use the long division method to remind ourselves. So long division, always the denominator comes here, numerator gets into the box. 4 goes into 3. 4 times one number will give us 3. It can't. So we have to bring what? A point and then add a 0 to it. So 4 times what number will give us 30 or close to 30. 4, 7, 28. So 28. When we subtract 28 from 30, we get 2. And we still have to clear everything. So we just have to add 0. Then 4 times what number will give us 25. And so if you remember, we said earlier that whenever we have point a number, we just bring 0 ahead of it. So right now we can read 0.75 That's the final answer. So we use a calculator. We have 0.75, long division 0.75. So right now we've changed common fraction 3/4 to decimal fraction. We have a second example, 4/5. We are told to change from common fractions to decimal fractions. We use the long division method. So denominator will come outside, then numerator will enter. So it can work. We have to put a 0, but before the 0 point. Okay, so 5 times one number will give us 48. 5, 8, 40. Our final answer is what? 0.8, but then we have to bring 0, so 0.8. So common fraction 4/5 is equal to decimal fraction 0.8. So 0.8 is also the same as 4/5, and 4/5 is also the same as 0.8. Whenever you divide and then you have a finite number, it's called terminating decimals, because you've terminated it, you've ended it. But we have something like think, let's say 2/9. With long division we can have 0.2222222. It keeps going on, then it's termed recurring recurring or repeating decimal. Repeating decimal. So there is no need for you to keep writing the twos. You can finalize it by 0.222, then 1, 2, 3. Okay, that is what we do for all recurring or repeating decimals. Comparing and ordering decimal fractions. In a decimal fraction, the position of the figures is important as well as their size. You have to take this into account when you are comparing and ordering decimals. So for example, as we have these numbers, about 0.309, 0.299, 0.0999, 0.3, 0.31, when you are working something like this, we are told to arrange them from the smallest to the biggest. Okay, so I'll show you two methods and then you go for whatever thing that works best for you. The first method, look at the tenths, and then when I say tenths, it ends with THS as we said earlier on. So we have 3/10, 2/10, 0/10, 3/10, 3/10, from the smallest to the biggest. So among all these tenths, which is the smallest? Definitely 0, right? So 0.099 will be the least, and then it's less than. Let's move on. From 0, we go to 1, but we don't have anyone here. We don't have anyone here. We don't have anyone here, but we have what? 2/10 here. And 0.299 will be the next, and then that will also be less than. Okay, so let's cancel. We are done with this. We've taken this out. We've left with these three decimal numbers. So 0.309, 0.3, 0.31. Okay, they all happen to have the same tenth, 333. So let's move on to hundredth, which will be 0. We don't have anything because it's just 0.3. And then in mathematics, whenever there is nothing, you can just replace with 0, okay, for you to be able to work things out. So this can also be written as 0.30. Now we have a hundredth. So 0 hundredths, 0 hundredths, 100. This is bigger than the rest. And then we are looking for what? The least to the biggest. So let's take this out. We'll bring it later. 0.31. Let's put it aside. Okay. And focus on these two for the meantime. So 0 hundred, 0 hundred. The same figures. So we move ahead. Thousandths. So 9,000th, there is nothing. You can put 0 here, okay? For it to be thousandth. And then 9,000th and then 0,000th. You know that 0 is absolutely the least. So 0.30 3 because we are focusing on this. 0.3. Okay. Alright. It's also less than. Now let's cancel. The thousandth. 0.309. And then what we took aside 0.31. So this will be our final answer. So you can go ahead and use whatever method you know about it, and then you get to know that you arrive at the same answer. Okay, so there is the first method. Let me teach you the second method too. Easiest method. Now we have to change them to division way. So 309 can also be written as 309 over how many zeros? 1, 2, 3. 1, 2, 3. Then 0.299 can be written as 299 over how many zeros? 1, 2, 3. 1, 2, 3. Then 0.999 can be written as what? 99 over how many zeros? No, there is a 0. Sorry. So it's 0.0999. Okay. And then we said earlier on, whenever 0 is preceding natural numbers, we can't write it. We just ignore the 0. And then we write the natural number. So 999 over how many zeros? 1, 2, 3, 4. So 1, 2, 3, 4 zeros. And then the next one, 0.3 can also be written as what? 3 over 1, 0. And then the last one, 0.31 can also be written as what? 3, 1 over how many 0? 1, 2. So 1, 2. Okay. Now to make things very easy for us, we look at the highest denominator, which is what? 10,000, because it has 4 zeros. And then we will do the same thing to all of them so that they will all have the same denominators. Okay. And then since we are adding zeros to the denominators, we add the same amount of zero to the numerator. Okay, don't get confused. It's very easy. We've changed it into the division way, numerator, denominator. Perfect. But then we look at the highest denominator and then do the same thing to the rest. Okay. And then as we are adding zeros to the denominators, we add the same amount of zero to the numerators. Very easy. So we have 4 zeros. 3 zeros here. We have to add 1 zero. We added 1 zero, so we add 1 zero here. 3 zeros. We need 4 zeros. Then we add another 0. There's 4 zero. No need to change it because this is what we are looking at to replace the rest. To do the same to the rest. 1 0. We need 3 zeros. 1, 2, 3. So the same way 1, 2, 3. Simple. 2 0. We need 2 zeros. 1, 2. 1, 2. You're done. So now it's easy for us to pick the least to the largest or the biggest. Okay, so we will look at the numerators. 3090, 2990, which is the least? 999. So this is the least. 0.099 is less than what continues. Okay, we'll look at this 2990. So 0.299 is less than or continuous. Okay, so we have 3000, have 3001, then we have 3000, so 0.3 is less than. We have 3001, then we have 3090, so this will continue 0.309, and then the last one will be 0.31. So we have the same answer as the first method. So we have two methods. Whatever works best for you, then you go ahead and then you choose it. Another example, but this time around we have whole numbers and then decimal numbers. Okay, so first of all, when you want to work this way, we also have two methods of working this. I'll show you the two methods and then you pick whatever works best for you. So the first method, we'll change all of them to mixed numbers. So 1.95 can also be written as one whole number, 95 over, after the point, how many numbers? Two, so that will be two zeros. Then two number, 5 over 10. Why? Because one number comes after the point. One whole number, 91 over 1, 2. Two whole number, 3. We don't write 03. Whenever a 0 precedes a natural number, we ignore that 0. But when it comes after the natural number or in between natural numbers, we include it. So 3 over 1, 2. So 1, 2. This is very easy. 69 over 1, 2. And 2 number, 71 over 1, 2. We have to make sure all denominators have the same number or numbers. So there's 100, there's 10, there's 100. So we have to change this 10 to 100. And then remember, whenever we add 0 down there, we add another 0 at the top numerator. Okay. All right. So the final step will be from least to the largest or the biggest. Okay. This is a mixed number, mixed number, mixed number, mixed number, mixed number. This is not a mixed number, so definitely it will be the least. Okay, so our final answer will be 69 over 100 is less than. Okay, for that, let's look at the whole numbers. We have 1, 2, 1, 2, 2. We are working from the least, so we work the ones first and then we come to the twos, and if there is threes then we move to it. Okay, so the ones. Okay, so between this one whole number 95 over 100 and one whole number 91 over 100, 91 is lesser than 95, so the next will be one whole number 91 over 100, and then this will follow one whole number 95 over 100. Okay, okay. In order to know what we are doing, let's cancel whatever thing that we've taken out. All right, so we are left with two number 50 over 100, two number 3 over 100, two number 71 over 100. Okay, so 2, 2, 2. All right, less than 5371, which is the least. Definitely 2 number 3 over 100 is out. 50 and 71, this will follow. So 2 number 50 over 100 is less than. Then the last one will be 2 number 71 over 100. Okay. And then our final answer will be, because this was the question and then you are told to arrange this and then you work this um outside the question. So make sure you finalize it by putting these figures, not these figures. Okay, especially when you are working in a theory question. Okay, all right. So 16 over 100 stands for 0.69. So it says to be less than 191 is for what? 1.91 is less than. This is for 1.95. It's also less than. Okay, it's for 2.03 250 will be 2.5, then it's less than 271, 2.71. So that would be our final answer. And then when the question was to be from the biggest to the smallest, you start from this, okay, 2.71, then you change the sign, okay, greater than, for 2.5, greater than 2.03, greater than 1.95, greater than 1.91, greater than 0.69. Okay, so arrange these numbers from the smallest to the biggest. This is what you do. Arrange these numbers to from the biggest to the smallest. This is what you do. Okay, and with the second method, you pick these because we changed the decimal numbers to mixed numbers, so it's kind of the same, but then you may want it that way. So okay, so 71 over 100. All right, you just have to change them to improper fractions. So 1 times 100 is 100, plus 95 will be 195 over 100, and then this will be 250 over 100. This will be 191 over 100. This will be 203 over 100. This will be 16 over 100. This will be 271 over 100. Okay, so you are told to change from smallest to the biggest, and then you just look at the numerators because we have all the denominators to be the same. So 195, 250, 191, 203, 69, 271. So 69 goes for 0.69. It's less than. We are done with this. The next list will be what? Okay, 191, right? 191 goes for what? 191 goes for what? 91 goes for 1.91. It's less than. We're done with this. Then 195 goes for 1.95. Is also less than. 203 goes for 2.03. It's also less than. 250 goes for 2.5. It's also less than. And 2.71. So we can see that they all have the same answers. Okay, so 203. So we have two methods. Whatever you think is very easy for you, you go for that. Addition and subtraction of decimal fractions. When adding and subtracting decimal fractions, it is important to keep decimal places in the correct column. Okay, so the decimal points one under the other. This ensures that we get tenths under tenths, units under units, tenths under tenths, hundredths under hundredths, and so on. And we then add the numbers as if there were no decimal points. Okay, so there are three examples left. So with the first example, 2.6 plus 3.84 plus 12.96. Okay, so the first one, always bring the number that has a lot of whole numbers in it, and then the rest will continue. That will be very easy for you. So we have a whole number of 12. So that will come first, 12.96, then plus 3.84, and then plus 2.6. Okay, there is no number, so we bring a 0. As I said, in any mathematical problem, when there is nothing there, just bring 0 and then work your way out. Okay, all right, so we are told to add these. Since the decimal point follows each other, we have no problem. Okay, all right, so 6 plus 4 will give us 10, so 0, and the 1 comes here, 10, plus 8 is what? 18, 18, 19, 20, 21, 22, 20, 24, so 4, then 2 comes here, 4, 7, 8, 9, 9, and 1, bring our point. So our final answer will be 19.40. Okay, all right. Let's move on to question 2. So we are told to subtract 6.74 from 12.8. So 12.8 minus 6.74. Always make the decimal point come after the other. This time around, there is nothing here, so as we said, we put a 0. Okay, carry 1, 10, subtract 6, 7 from 7 is 0. Know that we took that, so 0.6 from 12 is 6. So this will be our final answer. Okay, all right. Then the last example, 9.8 minus 12.63. This is a funny question because we are told to subtract the bigger number from the smaller number. Okay, no worries, just do the normal subtraction, then after that you put the negative sign before the answer. Okay, all right, so let's bring the 12 first. 12.63 minus 9.8, bring the 0 here. Okay, all right, so we got 3 here, we bring 1, making what? 16. 8, 8.11 here, so 9, 10, 11, 2. So we have 2.83. But remember, it was other way around, so you have to bring the negative for the final answer to be negative 2.83. Let's work this interesting question. By how much is the sum of 0.45? 0.45 and 0.312 different from 0.96? Sum means addition, different means subtraction. So that means sum of these two, will add these two, and then the difference is what we subtract from the 0.96. Okay, all right, it's very simple. So let's first of all add 0.45 plus 0.312. This also could have been written as 0.312 plus 0.45. Okay, in either ways, just add 1 0 here, just add 1 0 here. Okay, so when we add, we get 2 here, 6 here, 7 here, 0. We are not done. We need to subtract it from this. The other question said, by how much is the sum of this different from this? Okay, so 0.96, then 0.762. Okay, you bring 0. We are subtracting. So we take 1, which is what? 10, 8, 5 here, so we take 1, 15. 6 from 5 we go at 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 9. Okay, 8 is here, so 1.0. So our final answer will be what? 0.198. Multiplication of decimal fractions. To multiply decimals, first we multiply the numbers as if there were no decimal points. Then we count the number of decimal places altogether in the numbers. This will be the number of places of that product. Okay, there are two ways of solving these kind of multiplication questions. I'll show you the first one and then the second, and then pick whatever works best for you. So the first one, we are saying that you can just ignore the decimal and then just multiply it in the normal way. So 291 times 12. Okay, all right, let's go at 2 and 2. So 2, 2, 9, 18, 8, and then 1, 2, 2, 4, then 5. 1 times 1 is 1, 9, 2. Then we add them. 2 can bring 0 here. Okay, 9. 9 plus 5 will give us what? 14. So 4 and then 3. So final answer will be 3,492. But remember, we are multiplying in decimals. And then we said after you multiply it in a normal way, then you can count the number of decimal places and then you equate it in the final answer. How many decimal places do we have? 1, 2, 3. Okay, so 1, 2, 3, then point. So final answer will be what? 3.492. That is the first method. Let me show you the second method. Okay, so the second method will be just go ahead and then second method. Okay, so 91 over how many numbers? So 1, 0 times 12 over how many zeros after the point one number? So just 1 0. Okay, then we'll go ahead and multiply 291 times 12. Let's use the calculator. So 291 12 will give us 3,492 over 100 times 10 will give us what? 1,000, right? Okay, after that, how many zeros? 3. Therefore, we will make sure we place the decimal point after 3 counts. So 1, 2, 3. So it will be in between 3.492. And then you see that we have the same answers. Okay, so you can either pick the first method or the second method. We go to the second question. We work the first method and second method. Okay, so the first method, we said when we have a question like 1.45 times 2.8, you just ignore the decimal points and then you work it in a normal way. So 145 times 28. Okay, all right. So 5 times 8 give us 40, so 0, 4, 40, 32, 32, 45, 36, so 6, 3, 8, 9, 10, 11, 1, 1, okay, 5, 2, 10, 0, 1, 2, 8, 9, 2, 3, then we add them, 0, 6, 10, 0, 2, 4, okay. 1, 2, 3, 1, 2, 3. Put a point there. So our final answer will be 4.060. Okay, let's jump to the second method. Second method will be 145 over how many zeros? 2. 1, 2 times or 28 over how many zeros? 1. So 145 times 28. Let's use a calculator. So 145 times 28 is 4060 over 100 times 10 is what? 1000. So 1, 2, 3, we move 3 places. 1, 2, 3. So we have what? 4.060 is the same thing as what we had here. We move to the last example. So we have 0.1 times 0.2 times 0.3 times 0.4. Okay, the first method, you just multiply it as if there is no point. So 1 times 2 is 2, 2, 3, 6, 6, 4, 20. Okay, so 20. Don't get confused. Okay, we just ignore the point. So we ignore the point. So 1 times 2 is what? 2. Okay, and then that same 2 we multiplied by what? The 3, which is what? 6. And then the 6 we had we multiplied by what? 4, which is 20. That is why we had 20. Okay, okay. So 20, and then how many decimal point do we have? Places do we have? So 1, 2, 3, 4. The same way we make sure we count 4. So 1, 2, 3, 4. The points will be here. 0, 0. So our final answer will be what? 0.0020. But then know that whenever there is nothing, you just replace it with what? 0. So final answer will be 0.0020. Okay, let's use the second method and see if we arrive at the same answer. So 1 over what? 1 0 times 2 over what? Another 1 0. It continues. 3 over 1 0 times 4 over 1 0. Okay, 1 times 2, 2, 2 times 3, 6, 6 times 4, 20. So 20 over 10 times 10 is 100, and then 10 times 10, 100, then 10, 10, 10, 100. Then 100 times 100 is what? 10,000. Okay, because 1, 2, 3, 4, 0 is 1, 2, 3, 4. When you use the calculator, you have the same thing. Okay, so 10,000. Okay, this we have to count how many zeros. 1, 2, 3, 4 zeros. So let's write the 20 and let's count 1, 2, 3, 4 zeros. So the point will be here. Then in between we put zeros there. So we have, let's come here. We have 0.0020, and then you put a 0. And then you realize that 0.0020 is the same as that. Division of decimal fractions. So division of decimal fractions is very easy if the divisor or denominator is a whole number. Okay, all right. So let's use this example. We have first method and second method, but I always love the second method because it's easier for me. But I don't know if you will love the first method. So, anyways, we will arrive at the same answer. But then, just go for whatever thing you think is very easy for you. Okay. So with the first method, we have to make sure we multiply both of them by 10. Okay. So, the first one. 0.48 times 10 divided by 0.2 times 10. So with our calculator, 0.48 times 10, we will get 4.8 over then 0.2 times 10, we will get 2. Okay, all right. So 2 goes here 2, and then it goes here 4. So our final answer will be 2.4. Okay, all right, put a point there. So there's the first method. All right, and then the second method, we go by writing 48 over 100. Why? Because two numbers comes after the decimal point, divided by 2 over 10 plus one number. Okay, all right. And then if you remember what we did earlier on, we need to change this division sign to multiplication, and then also change 10 to be the numerator and then 2 to be the denominator. Okay, all right. So 48 over 100 times 10 over 2. Okay, now you can do any cancellation. So 10 goes here, 1 goes here, 10, and 2 goes here, 1 goes here, 24. Okay, and then 2 goes here, 5 goes here, 12. So we have 12 over 5. So if you punch it on the calculator, 12 divided by 5, you'll get 2.4. Okay, I always go for the second method. I don't know about you if you choose it first. So yeah, all right. And then also I think people will be thinking, okay, you said earlier if we are multiplying with decimal fractions, we should, okay, let's see, 48 over 100 times 10 over 2. Okay, we should just go ahead and multiply the numerators and then denominators and then go. Okay, if it was to be the other way around, 48 over 100 times 2 over 10, then that's what we were going to be doing. Okay, do not get confused. Okay, all right, because we had to change the division sign to multiplication and then also change upside down. This is what we have to go for, not this whereby we just multiply 48 by 2, whatever thing we get, then 100 times 10. Okay, all right, these are some of the little reasons why math is kind of difficult for some people, but if you follow the rules, you are good. Approximations. Many numbers we use are approximations to the exact values. They are not exact, but they are about the right size. For example, in a football match, the exact number of spectators counted at the match is 26,943. An approximation of this number will be 27,000 because it gives us a good idea of the number of spectators at that match. Okay. Also, all measurements are approximations. They are accurate to stated level of accuracy. We will find or we will often need to find approximate values during our our studies under approximations. Okay, so we will be focusing on these rounding values to the stated number of decimal places. So decimal places, that will be the topic, subtopic under approximation, and then significant figures, and then also rounding numbers to the nearest tenth, hundredths, thousandths, and we go. It goes on. Rounding numbers or values to the nearest unit, 10, 100, 1000. It goes on. Okay, so we under decimal places, we have what we call a number that comes after the decimal point is termed as a decimal place. Okay, so for example, 0.345, all these numbers are what decimal places, and so this is what one decimal place, two decimal place, 3 decimal places. So this number is said to have 3 decimal places. The same thing applies to this, but this 1 decimal place. So 1.8 is said to have only 1 decimal place, and then 40795 is said to have how many decimal places? 1, 2, 3, 4, 5. 5 decimal places. We don't count from right to left. We count from left to right. So 1, 2, 3, 4, 5. 1, 1, 2, 3, 1, 2, 3. 3 decimal places, and then 5 decimal places. Okay. All right. So we are doing this under decimal places. All right. So we have 5.3612. So as I was saying, 3 is what? The first DP, decimal place. 6 is the second DP. 1 is third DP. 2 is fourth DP. If there should be another number, let's say 6, that would be what? The fifth decimal point. It goes on and on. So under decimal places, let's look at these examples. 0.371, and then we are told to change to 1 decimal place. Okay, so 1 decimal place, as we said, we count from left to right. So 1 decimal place, 2, 3. But we are told to change to 1 decimal place. So we are changing this. We are just, approximation. We are just summarizing it. This 0.371. Okay. So approximation can also be termed as what? Summarization. Okay. Or simplification. So 1 decimal place, we look at the next number, which is 7. Now, 0, 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Whenever the next number falls in between 5 to 9, 5, 6, 7, 8, 9, just turn it to 1 and then add it to that decimal place we are talking about. But then when it falls in between 0 to 4, just ignore it. Okay. All right. So 0.371, 1 decimal place 3. The next number is 7. It falls within that. So we'll change it to be what? 1, which is 0 point. And then that 1 will be added to the 3. So what? 4. This will be our final answer. Okay. All right. The same question. Let's say change to 2 decimal place. Okay. 1 decimal place, 2 decimal place. The next number is what? 1. It falls here, so we'll just ignore it. So 0.37 will be our answer. Okay. All right. Let's work for 16.054 and change it to 1 decimal place. So 1 decimal place, this falls in there, so we'll just add 1. So it will be 16.1 final answer. What about 2 decimal place? 5. The next number is 4. We can't add, so we just write 16.05. Ignoring the 4. Okay. All right. Let's work the last one. 9.1865. 1 decimal place will be what? 9 point. The next number is 8. So we add 1 to what? 2. 2 decimal place will be what? 8. The next number is 6. So we can still add. Okay. So 9.1 what? 9. Okay. Let's continue. 3 decimal place. The next number is 5, which is falling under this, so we'll add 1 to it, which will give us 9.18. What? When we add 1, 7. We have another example. So we have this amount, we have 5.96. We are told to change to 1 decimal place, so 5.96, 1 decimal place, 1 decimal place. The next number is 6. Falls here, so we add 1. Okay, when we add 1, it will be 10. So write what? 0, then point that 1. will be added to the 5, so 6.0. Okay, do not panic. This is how I went about it. So 5.96. Okay, we are told to change to one decimal place. The next number, which is 6, falls between this. Okay, so we'll add 1, so it will be cleared and turned into plus 1. 1 plus 9 is 0 and 6. Okay, that's how we had it. So let's use the same method for this. Question 2, 1.2496. Okay, 3 decimal places, so 1, 2, 3. So 9. The next number is what? 6. Okay, plus 1. So it will be what? 1.2 plus 1 is what? 10. So 0, then 5. So 5, what? 0. There's it. Okay, so again, let's go by this formula so that we get it. 1.2496. 2 are 3 decimal place. 1, 2, 3. The next is 6. So plus 1. It will be wiped off to plus 1. Okay, so 10, 5, 2.1. The same thing. Okay. We jump to significant figures. In significant figures, whenever a 0 is preceding natural numbers, we don't count it as a significant figure. But whenever it's between natural numbers, then it's a significant figure. Significant also means important number. So 0, no, not a significant figure. 0, this 0 is not a significant figure. This 0 is not a significant figure. But this 0 is a significant figure. Okay, all right, because it's in between what? Numbers, natural numbers. Okay, so we are told to work this number for one significant figure. So we won't count these zeros because it's preceding the natural numbers. So we start with 9. So 9 is the first significant figure. And then we look at the next number, which is 4. So if you remember, we said 0, 1, 2, 3, 4. You just ignore. And then 5, 6, 7, 8, 9. You add plus 1. Okay. So first significant figure 4. So we just have to do what? Ignore. So number 1, final answer will be 0.009. Okay. All right. 2. Very significant figure. So 1, 2, 3. We look at the next number, which is 7. It falls under the plus 1, so we turn it to plus 1 to be what? 15.1 will be our final answer. Then 3 says 2 significant figure. 0 is not a significant figure because it's preceding natural numbers, so we start with 1, 2. So we are looking at 5 as the second significant figure. The next number is 6. It falls under plus 1, so plus 1 will be what? 0.416. These will be our final answers. Sometimes you just have to replace zeros to fill some places with to just keep each figure as the place value. Okay, sometimes you just have to fill some places with zeros to keep the place value of each figure. Okay, all right. So let's look at this example and then you mean what I mean. You get to understand what I mean. So 287,530 for significant figures. So Number 4 for significant figures. So 1, 2, 3, 4, which is the 5 we are looking at. The next number is what? 3. The 4 says, so we will ignore 2, 8, 7, 5. We can write this. We just have to replace the rest with 0. Okay, for it to be complete, so that we know that approximation 287,530 is what? 287,500. Okay, right. 3 significant figures. 1, 2, 3. Okay, the next number is 5. So we change it to 8, 8, then what? 0, 0, 0. Okay, 6. 2 significant figures. So 1, 2. The next number is what? 7. 4 is there. So we change to 9. And then we replace the rest with what? Zeros. 1, 2, 3, 4. Then the last one significant figure, which is 2. So we look at the next one, which is 8. So we change 3, replace the rest with zeros. 1, 2, 3, 4, 5. Let's take notice of these differences. Okay, so if its value like 287,530, we said that when after changing it, you replace it with zeros. Okay. Okay, so 2 decimal place 1, 2, which is the next number is 7, so 9. So we have 2, 9, then the rest 0, 0. The difference is that with this, you will not replace with any 0. Okay, because this is a value and this is just a decimal number. Okay, so with this 2 significant figure, this is not a significant figure. That no, 4 is the first significant figure, but it's the second significant figure, which is what? 9. We look at the next number, which is 6. So we can add 1 to it, making it what? 0.05. Okay. 0.5 and 0. We have to add 0 to it because when we add 0.049, 6 will be turned to a plus 1, 0 and 5 and 0.0. So this should be our final answer. So this is the difference, okay? Because it's a value, you replace it with the zeros. Because there is a decimal number, you just ignore the rest. Round the numbers to the nearest 10, 100, 1,000, and it goes on. 10,000, 100,000, millions. Okay, so we have a figure like 9,873,456. And then we are told to round it to the nearest million. So this the million because ones, tens, hundreds, thousands, okay, and tens of thousands, hundreds of thousands, then millions. So millions. The next number is 8, which is plus 1. We add it to it, so we get what? 10. And then all these will be replaced by what? Zeros. Why? Because they are values, not decimal numbers. So the nearest million is what? 10 million. So maybe we have spectators of 9,873,456, and then you want to round it up, approximation. You could just say spectators are 10 million. Okay, all right. So nearest 100,000. The same way you move to the 100,000, that will be the 8. The next number is what? 7. So it will be 9. So 9, 9, all the rest will be zeros. It's very simple. Okay, then we move to the 10,000. The next is what? 3. We have to ignore because it's not more than what? It's not 5 or more than 5. So we just write 9, 8, 7, and then 0, 0. Okay. And then the next one will be what? 1000, 3. The next number is 4. We have to ignore again because it's not 5 or more than 5. So 9, 8, 7, then 1, 3, then 0, 0, 0. Okay. Nearest 100. There is 100, 4. The next number is what? 5. So we can round it to be 5. So we have 9, 8, 7, 3, then 5, then 0, 0. Then lastly, nearest tenths. This will be the tenths. So 9, 8, 7, 3, 4. The next number is 6. So we change it to what? 6. Yeah. Very easy. Okay. We move to rounding numbers to the nearest tenth, hundredth, thousandth, etc. Whenever you see th and then know that it involves a point. When there is no th, it's just a whole number figure. Okay, so ones we solved were without th. That's why it had millions. For this, we can say million. We say 987.3456. Then the first question says we should change it to a whole number. So this is the whole number. These are the decimal numbers. And then the whole number, right after it, the 3 falls in the ignore section because it's not exactly at 5 or more than 5, whereby we can add 1. Okay, so the whole number will be what? 987. That's it. There is no need for you to bring zeros because again, it's not a value. There is a decimal point, so it's decimal numbers. Okay. 10th. With these, after the point is what we have as what? 10th, 100th, thousandth, and it goes on. Okay. All right. So this will be the first 10th. And then we look at the next number, which is 4. It's not exactly 5 or more than 5. So we just ignore it. So we write what? 987 point what? 3. That will be it. Then 100. That will be the 4. So 987.34. Let's look at the next number 5. So we can add 1 to it. So 3, 5. Okay. Then 1000. We are looking at this. All right. So the next number is more than 5. So we add 1. So 987.346. So these will be our answers. Standard form. When numbers become very small or large, standard form, or what we term standard index form, is used to make them manageable. So let's take notice of what is on the board. We have to know that the value of n, that is the power of 10, in any standard form shows whether the number is greater than 1 or is a fraction. Okay, and then the second thing we have to notice, if n is positive, the number is 10 or more. So whenever the n, which is raised to the power 1, when it's positive 6, the answer will be what? More. Okay, so 1 times 10 raised to the power 1, because it's what? Positive. It's what? 10. 4.6 times 10 raised to the power 6 is positive 6. So we get 4,600,000. Okay, then what we have to study also is if n is 0, the number is between 1 and 0. So for example, we have 1 times 10, okay, raised to the power 0. we will have only 1. And then also 4.6 times 10 raised to the power 0 is what? 4.6. Why? Because any time you see 10 raised to the power 0, change the whole thing to be 1 and use it to multiply whatever number is said there. Okay, it's very simple. Very, very easy. And then we move to the next one that we have to take notice of. So if n is a negative, then the number is a fraction. Okay, so let's see, 3 times 10 raised to the power negative 1 is what? A fraction, which is what? 3 over 10 or 0.3. Okay, the same way 4.6 times 10 raised to the power negative 3. Because it's negative, you get what? A fraction or a decimal number. So 0.0046 or what? 46. This can also be written as 46 over 1, 1, 2, 3, 4. 1, 2, 3, 4. 0.3 can also be written as what? 3 over 10. And then we should know that to understand and use standard form, we must be able to multiply and divide by powers of 10. Okay. And then we have to also take note of these. Whenever we multiply a positive power of 10, it makes the number larger. So when we have 4.6 times 10 raised to the power 6, the final answer will be what? A bigger number or a larger number, which is 4,600,000. And then the other way around, when we multiply by a negative power, you get what? A smaller number. So the same thing, 4.6 times 10 raised to the power negative 3, we have a very small number to be 0.0046. So that's the difference. When it's positive, you get a bigger number. When it's negative, you get what? A smaller number. Let's also note this. If we move the decimal place to the right to get the ordinary number, the power is negative. And then also, whenever we move the decimal place to the left to get an ordinary number, that power will be positive. Okay, so in standard form, when we are moving decimal point to the right, we will get a negative what? Power. Okay, because we are making it what? Smaller. And then when we are moving it to the left, we get what? A positive, because that would already be a bigger number, and then we want to make it what? Smaller number. So let's take note of that. So we have examples on the board. Okay, so we are told to write. Let's remember that when we are moving decimal place to the right, we get what? A power of negative. And then vice versa, when we are moving to the left, we get a power of positive. They know that under standard form, every number there is invisible point or decimal point just after the number. Okay. All right. So that is what we will move. And then we are saying when we are moving towards the left, we get what? A positive power. So I want to move 1, 2, 3. So 2.0 times 10. How many times do we remove? 3. Positive. Okay. If we are supposed to move from maybe the point was here, maybe we have to 0, move 1, 2, 3. It will be what? 2, 0, 0, 0 times what? 10. How many times? Negative 3. You see the difference? Because we move from right to left, it's positive. From left to right, it should be negative. Okay, so we are doing it this way first, and then we'll go to that part. All right. Second one, which is 10, we move 1. So 1.0 times 10. How many times do we move? 1. The third one, we're moving 1, 2, 3. So 4.6870 times 10. How many times do we move? 3, 3, and 4. Move 1, 2. So 3.5607 times 10 raised to the power 2. Okay, then 5. Move 1, 2, 3, 4. So 4.1460 times 10 raised to the power 4. And then the last one will be 1, 2, 3. So we have 3.2017 times 10 raised to the power 3. Very easy. Okay, so as we said, when we are moving the decimal point towards the right, we will have a negative power. The first one was towards the left, so we had a positive power. This time around, we will have a negative power. Okay, so let's work this out. We'll move 1, 2, 3. So 1.8 times 10 raised to the power negative 3. Okay, 1, 2, 3. 1.0, because point nothing, we said you put 0, times 10 raised to the power negative 3. The same thing, so 1. So 2.0 times 10 raised to the power negative 1. Then 1, 2, 3. So 4.3216 times 10 raised to the power negative 3. Then 1, 2. So 5.003 times 10 raised to the power negative 2. Then lastly, 1, 2, 3, 4, 5. So 3.627 times 10 raised to the power negative 5. And in some cases, you'll be told to further change to significant figure. So with this example, 4687.02, you are told to write it in a standard form. After that, to a three significant figure. It's very easy. Okay, so again, 1, 2, 3. So 4.68702 times 10. No, remember that to the left is always what? Positive. Moving to the right is what? Negative. This time around we move to the left, so it will be what? Positive. How many times do we move? 1, 2, 3. So positive 3. Okay. All right. And then there is answer, but then they said to what? A three significant figure. So 1, 2, 3. The next number is 7. You can change it. So it will be what? 4.69 what times 10 raised to the power 3. Okay? Because 7 is more than the 5. We change it to +1, add it to the 8, making it 9. So this will be our final answer. So to change a number given in standard form to an ordinary number, what you have to know is whenever you see that the power is positive, then move the decimal number towards the right. When it's negative, move towards the left. Okay. All right. So this time around it's positive 4. So move the decimal point towards the right. How many times? 4 times. So we want an ordinary number. We said positive 4. So we move 4 times. 1, 2, 3, 4. And then we will place with zeros. So right now we have what? 2000. We have 23,000. Okay, and then the next one, 4.3216, because it's negative, you move towards what? The left. Okay, so we have 4.3216. It said we should move how many times? 3 times. So because it's negative, we are moving to the left 1, 2, 3 times. The point to be here, 0, 0, then we bring 0. So final answer will be 0.0043216. These are the differences. Addition and subtraction of numbers in standard form. So, because they all have the same powers, just go ahead and then add plus 1.6. 8 plus 6 is what? 14, so 4, then 3, 4. So the final answer will be what? 4.4 times 10 raised to the power 4. Okay, so question 2, the same power, so we subtract 2.5 and minus 1.6. Okay, cannot work, so we have to borrow 1, which will be what? 9 and what? 0 and times 10. Okay, so this is not in a standard form. We have to change it to a standard form. And then we said when we move from a decimal point from towards the right, it will have what? A negative power. Towards the left, we'll have a positive power. But we'll be moving towards the right, so we have what? A negative power. So 9.0, because we move times how many times? 1 times negative 1. Okay, and this can also further be written as 9 times 10 negative 1. But remember that we have 10 raised to the power negative 4. Okay, all right, we need to add the powers. Why? Because it's a multiplication sign. If it was to be division sign, we would have subtracted. Okay, so let's add. 1 plus 5 is 5, negative plus negative is what? The same negative. Okay, so our final answer will be 9 times 10 raised to the power negative 5. This is in a standard form. Now we move to the example whereby we have different powers. This time around we don't have the same powers 4, 4, but we have different powers 4, 3. So in order to work these kind of examples, what we do is we express each number in full. Okay, so 2.8 will be expressed as a normal or a value as a value. So 4 means we move 1, 2, 3, 4. We put zeros in between. So right now 2.8 is 28,000. We do the same thing for 1.6. It says we should move 3 times 1, 2, 3. So 1, 2 plus 1,600. We add them 0.0692. Okay, so we have 29,600, but then we are told to leave in a standard form. If the question tells you to leave in a standard form, then know that this is not your final answer. Okay, so in a final answer in a standard form, we move back. The decimal point will be here. So 1, 2, 3, 4. So 2.96 times 10. How many times did we move? 4. So this will be the final answer. Okay. All right. And then we move to the second question. we are told to subtract different powers. So we can't just go ahead like we did the first. So the same way as this time around it's a negative. So we will move the zeros towards the left. 2.5. How many times? 4. 1, 2, 3, 4. So 0.000. So right now we have 0.00025. Okay, we do the same thing for 1.6. How many times do we move? 5. 1, 2, 3, 4, 5. So 0.0. So what do we have? Points. How many zeros? 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 6. And then 0. Just put a 0 here, okay, for it to be complete. We are subtracting. So we pick 1 from this, making 10. So 4. This tends to be 4, so 3, have 2, have 0, have 0, have 0.0. We are told to leave in the standard form, so we can't leave it that like this. So we move back the cells 1, 2, 3, 4. So our final answer will be 2.34 times 10. How many times did we move? 4. But then we move towards the right, so it will be negative. So this will be our final answer. We move on to multiplication and division of numbers in standard form. It's very easy. Very easy. Okay. So we have 9.3 times 10 raised to the power 5, or in the bracket, times 2 times 10 raised to the power 3, or in the bracket. So we'll separate the decimal number 9.3 with this times 2. We'll separate it, okay, from the powers times 10 raised to the power 3, okay. And then 9 times 3, 9.3 times 2 will give us 18.6. Times 10. Multiplication, we add the powers, okay. Division, we subtract. Let's remember that. So we are adding 5 and then 3, we get 8. That is not the final answer. Let's apply the laws of indices. I will go over the indices, and then if you've forgotten about indices, you'll be able to remember everything again. But then laws of indices, we just have to put the 10 raised to the power 8 aside. Let's work this first. We'll move on. So this will be 1.86 times 10. How many times did we move? 1. To the left is what? Positive. Okay. If it was to be the right, it will be what? Negative. Okay. So right now we have 1.86 times 10 raised to the power 1. Let's bring this times 10 raised to the power 8. Okay. So 1.86 times 10 multiplication. So we add raised to the power 9. This is the final answer in the standard form for this multiplication question. We move on to the division. So just like multiplication, very easy to. So 2.16 times multiplied by, oh, sorry about that, divided, sorry, so divided by 2.7. Okay, then we group the 10, 6 divided by 10. So, okay, All right, so let's work 2.16 divided by 2.7. Okay, so we have 0.8, okay, times 10 division sign, so we subtract 2 from 6, okay, we get 4. This is not the final answer. Loss of indices, so we move 1 8 times 10. How many times do we move? 1. We move towards the right, so negative, okay, times the 10 raised to the power 4. All right, this time around we have to add, but negative 1 and then 4 or subtract, okay. All right, so final answer 8 times 10 is what? 3. And then positive is 2, 4, and then negative is 2, 1. So you'll maintain the positive 3. But if it was to be negative 4 and then positive 1, then the final answer will be what? Negative 3. Okay, so this will be the final answer. Working these last two examples and then we wrap up for standard form under decimal fractions. Okay, so the same process of 3 times 4 and times 10 raised to the power 4 times 10 raised to the power 6. So 3, 4, 12 times 10, we add them, okay? So minus 4 plus 6, we have to subtract because remember indices, different signs. So we get 2. Then what number has, what big number has the sign? So 6 has the positive sign, so we maintain it, okay? All right. That's not the final answer. Okay, we move on. Now there is a point here, okay? We move 1.2 times 10. We move to the left, so it will be what? Positive. Okay, times 10 raised to the power 2. So the final answer for standard form is 1.2 times 10. We add them. 3 is the final answer. All right, let's move on to the last example. So the same process, 6 divided by 4 times 10 raised to the power negative 3 divided by 10. Because there is nothing, you can just put 1, okay? But if it was to be 0, then this 10 whole thing will turn into 1. I mean, if it was 10 raised to the power 0, it would have been 1, okay? But 10, nothing can also be written as 10 raised to the power 1, okay? So let's divide 6 by 4 and we get 1.5. So 6. Okay, so we get 1.5, okay, times 10. Now we are subtracting, okay, minus 3 minus 1, the same signs, so we'll add, making what? 4. 3 has a negative 2, so negative 4, okay. And then looking at 1.5 times 10 raised to the power negative 4 is already in a standard form, so there is no need to continue working. This will be our final answer, okay. All right. Okay, so in summarizing everything, a standard form should always be a number, let's say 2, then a decimal point, then whatever number that will continue continues, then times 10 raised to the power -6 or 4 or whatever. So if we have something like 23 points 415 times 10 4. There is not a standard form. Always know that the standard form, the first natural number, then a point, and the natural numbers continue, then times 10 to whatever power it is raised to. Okay, so we move 2.3415 times 10. What a one number? 7, 8. Know that to put a number, an answer in a standard form, always the natural number comes, then decimal point, then the rest continue. Times 10 is to one number you had from moving the decimal point. Okay. All right. So we are done with standard form and decimal fractions.